This module describes the absorption and transmission of optical materials. After studying this module, you will be able to define absorption and transmission of optical material and also work with the transmission equation of optical materials. Let's take a look at the prism we have here in front of us. If we have irradiance of value E0 hitting the prism on the left hand side and having irradiance E exiting on the other side, of these two variables E0 and E are governed by this equation right here. Obviously E, the irradiance exiting from the right hand side, is going to be less than the irradiance arriving on the front side because of the absorption of the material. This factor here, e to the minus alpha x, is a modifying factor. It's always less than 1. It's a fractional factor and modifies E0 by that amount. Alpha is the absorption coefficient of the material and x is the thickness. Both the absorption coefficient and the thickness should be measured in the same units of length. Typically we use centimeters for both. In case you have to use millimeters, then make sure you have millimeters for both. Let's work with this equation. The equation for transmission, it's E is equal to E0 times e to the minus alpha x. If we divide left and right by E0, then what we're going to get is this. The E0s cancel out, and then we have E over E0, in other words, the transmitted irradiance over the incident irradiance is equal to e to the minus alpha x. So we can write this as E over E0 is equal to e to the minus alpha x, or E over E0 is what we call the transmission. So transmission is C over E0, or transmission is equal to e to the minus alpha x. So we have these two formulas which they have been printed over here on the top. This is equation 2, and over here this is equation 3. So we'll be able to use all of these three equations in dealing with transmission. Also, if you look down here on the bottom of the screen, if we take the ratio of E over E0 and multiply that by 100%, then we have the percent transmission. And we can have a formula for percent transmission using E over E0, or we can do the same thing with the e to the minus alpha x times 100%. In other words, we can operate on equation 2, multiplying that by 100% and get the percent transmission using this formula, or operate on equation 3, multiply equation 3 by 100% and get transmission that way. So let's look at our first example. The absorption coefficient of transparent cube of optical material is 0.5 centimeters to the negative 1. So let's create a little diagram right here. So we have a cube which has a 5 centimeter side, and then it has also an alpha of 0.5 centimeters to the negative 1, and we have irradiance hitting it on one side, and then this is what's exiting. This is E0 and this is E. So the question is, what is the transmittance of this material? So we need to find T. Okay, so if we go back to the previous slide, then we have a choice of either using equation 2 or equation 3. So based on what's given to us, x was given to us and alpha was given to us, it makes sense to use equation 3. In other words, transmission is equal to e to the minus alpha x. So transmission is e times minus 0.5 centimeter minus 1 times 5 centimeters. Centimeters to the minus 1 and centimeters cancel out. So transmission is equal to e to the 0.5 times 5 is going to give us 2.5. So it's e to the minus 2.5. And then you use your calculator to find the exact value of transmission. So now, here is the second example, which you need to practice yourself. Go ahead and pause the video, use your own paper, and try to solve the problem. When you are ready, after you finished it, restart the video and you will see the solution on the screen. So let's see how we solve this problem. Here we have transparent cube with an optical material of 0.5 centimeters to the minus 1. That's alpha is equal to 0.5 centimeters to the minus 1. And let's say the cube now is 10 centimeters wide, or the side of this, and we're asked to find the transmittance. So this is x. So this equation, this example is very similar to the previous problem. Since we know alpha and x, we should use this equation. Transmission is equal to the minus e to the minus alpha x, which gives us e to the minus 0.5 centimeter to the negative 1 times 10 centimeters. Centimeter to the negative 1 and centimeters cancel out. Then we have e to the minus 0.5 times 10 will give us 50. So the transmission is e to the minus 50. So you plug this in your calculator and you come up with the answer. Now let's continue with the second example. A laser beam of a radiance of 5 milliwatts strikes a rectangular optical prism at right angles with its surface. The beam coming out of the opposite side is measured to be 2 milliwatts. So let's create a little diagram so we can put all of the information on the diagram. So here's our rectangular prism, which has an incident beam of E equal to 5 milliwatts, and the beam coming out on the opposite side, actually this is going to be E0, and this is E is equal to 2 milliwatts. The thickness of the prism through which a laser travels is 7 centimeters, so that's your x is equal to 7 centimeters. And then the question is, what is the coefficient of absorption of this material? What is alpha? And assume that there are no reflections at the optical interfaces. There's no Fresnel reflections at this point, and also at the back here when the laser exits the rear surface of the prism. So how are we going to solve this problem? Well, knowing E0 and E, we can find the transmission. So the transmission is equal to E over E0, which is equal to 2 milliwatts over 5 milliwatts. Milliwatts and milliwatts cancel out. 2 over 5 is 0.4. So the transmission is 0.4. Now, what is the coefficient of absorption of this material? We need to use an equation that links transmission with coefficient of absorption, which is this form of the transmission equation. Transmission is e to the minus alpha x. So looking at this equation now, t is known, x is known, alpha is the only unknown, and e is a constant. So how do we solve an equation like this? We have to use logarithms, and the simplest way to do this would be to take the natural logarithm of both sides. So taking the natural logarithm of the left hand side, this natural logarithm of t is equal to the natural logarithm of e to the minus alpha x. And continuing here, we use the property of logarithms that when you have a number raised to a power, then you can rewrite this as bringing the power at the front of the logarithm. So this is the same as minus alpha x times the logarithm of what's in the parentheses, the logarithm of e. And in this case, the natural logarithm of e is equal to 1. So now we're left with natural logarithm of t is equal to the minus alpha x. Now this is a plain linear equation, and we can solve this for alpha. So if we divide left and right by minus x here, we're going to have alpha is equal to the natural logarithm of t divided by minus x, and plugging in the values that we have is going to be the natural logarithm of 0.4 over minus 7 centimeters. So alpha is, plugging in the 0.04 into your calculator, finding the natural logarithm and dividing that by minus 7. So the answer is going to be a number here to cm minus 1, because notice the centimeters in the denominator, so the unit of absorption is the inverse centimeter, or the inverse unit of length. So here is going to be the number centimeters to the negative 1. Okay, let's continue with practice example 2. So here is your second example, similar to the problem that we have just solved. So pause the video, solve this on your own with your own pencil and paper based on what you have learned so far, and once you're ready, once you have the solution, then restart the video to see the correct solution. Okay, so let's solve this problem. So you have a laser beam of radiance of 5 milliwatts striking a rectangular optical prism at right angles with its surface. So let's do the diagram again. So here's our prism. So we have the incident irradiance is 0, is 5 milliwatts, and then the transmitted irradiance is equal to 4 milliwatts. The thickness of the prism is 7 centimeters, and find the coefficient of absorption. Okay. So how do we solve this? The first thing that we need to do is, using E and E0, we can find the transmission. Transmission is equal to E over E0, which is equal to 4 milliwatts over 5 milliwatts. Milliwatts and milliwatts cancel. 4/5 is the same as 8/10, or 0.8. So the transmission is 0.8, or 80%. Then we go to this form of the transmission equation, e to the minus alpha x, And now we have t is known, x is known, the only unknown is alpha. So we solve this equation for alpha, and to do that we need to take the natural logarithm of both sides. So ln of t is equal to ln of e to the minus alpha x. Then we continue, remembering the property of logarithms. When you have a power raised to an exponent, you can bring that exponent outside the logarithm in front of it. So this is minus alpha x natural logarithm of e. And now we should remember that because here we're using a natural logarithm, is logarithm base e. So logarithm of e base e gives us 1. So we can solve now here for alpha, and alpha is equal to natural logarithm of t divided by minus x. So over here, going up and picking up the information from above, we have ln of 0.8 divided by minus 7 centimeters. So we plug those numbers in our calculator and we come up with the answer for this question.